Yeah, good morning, class. Welcome again to our Metric Up channel, where we are going to continue today with geomorphology revision questions. I've just developed some questions on geomorphology that I'm quite sure that they are going to help us in getting an understanding and a review of our chapter. So without wasting any time, we just wanted to answer these questions, the multiple choice short questions there, so that we can be able to get a thorough or a complete revision of the questions that I've just gathered today. Our first question is on a river system and its tributaries is known as what? A river system and its tributaries, what is that called? We are saying, what is a river system and its tributaries? Which we are saying is a river and its tributaries is known as a what? It is known as a river system. 2.1.1. We are saying it is known as a river system. Question 2.11. Answer is C. You know, a drainage basin, when we're talking about a drainage basin, it's an area drained by a river system. That is a drainage basin. And then surface runoff, you know what? That is water that flows on the ground, either during rain or after rain, that would just drain off the land, that does not infiltrate there and there. So we are saying the answer is C, it's a river system, which is a river and its tributaries. 2.1.2, the high-lying area separating two drainage basins is a dash. That area that separates two drainage basins, it is called a watershed. 2.1.2, it is called a watershed. It is called a watershed A. If you can check, we are saying a source is where the river starts, and then the water table, we are referring to the highest level of water saturation underground that we call water table. So a watershed, it is an area that separates two drainage basins, which is A. Where two or more rivers join in is known as dash. Where two or more rivers join it is known as a dash. It is known as a confluence. If you can look on a river system, there is a question that we did in our previous presentation, which we tried to identify the river system or the river features from the source to the mouth. So where two or more rivers join, it is known as a confluence. That is D. It is known as confluence. Where two or more rivers join together, it's called a confluence, which we are saying when we are into that again, I want you to remember again that this is the confluence. It also helps us in terms of understanding stream orders, which we are going to see in our next question that comes there. Next question, it is referred to the sketch below of the drainage basin of to answer question 2.1.4 to 2.1.6. The sketch above represents a drainage pattern. I'm sure like you understand the drainage patterns. A drainage pattern that resembles the branch of a tree, it is known as a what? It is known as dendritic drainage pattern, which is B, dendritic drainage pattern. It is dendritic drainage pattern, which is what? Which is B. It is dendritic. Right here, you understand that is whereby to say the streams are deviating from a high central point. There is a high-lying area which the streams would just divert, or they run the water off from that area. And then rectangular, you are saying the streams are just flowing in a rectangular way, which would form some different structure, as unlike from this one, which resembles the branch of a tree. Is called dendritic drainage pattern. Our next question, if you can check our next question, it wants us to refer to stream order. Stream order at X. Identify the stream order at X. I was saying in terms of stream order, number 2.1.5, it wants us to identify stream order. So what happens here is that we need to understand to say the first streams that catches the water from the catchment area, which are collecting their own waters, they are called first order streams. So when streams of the same order are meeting, they form the highest order stream, or they form the next higher order stream. So stream ordering is constructed based on the network of streams, whereby streams of the same order joining together, they result in the formation of a stream order of the next, they result in forming the next order stream. So in this case, we are saying, if we look on this stream here, it is stream order, first order, and then first order, when they join together, they form second order. However, here, this one is a first order again, and here we have got first order, this is first order, and then when they join together here, they form a second order. This one is a first order. So what is happening here, it's a first order, and this one is also a first order stream, which we are saying it is first order and first order stream. There they join and they form second order stream there, and here again is second order stream, which we are saying they are going to form third order is formed there. And then in this case again, we are saying second order and second order, when they join together, they are going to form what? They are going to form third order. So in again, I just wanna let you see here is first order, first order, first order, and then we are saying at this point, what is happening? We are saying this is a second order, and this is second order. So second order, and then when these join together, they are going to remain forming, we are going to have, as you can see here, we have got third order there. So we remain considering that this is our second order stream again, which is joining with the second order there, second order and second order there. Hence, we are going to say at X, it is third order. At X is a third order stream. It is a third order stream that you can see there. So the question wants you to identify, to say, what is the stream order that is formed at position X? So what I'm saying is, when streams of the same order join, they form a higher order stream. As I've illustrated in this case, that first order and first order, they form second order and second order, they form what? They form third order. But in the case whereby streams are joining, let's say first order and second order are joining, they remain considering, or the stream order that is formed next is the one of the highest number, or of the higher order, which is saying first order and second order joining, we remain having second order. As you can see there, we are saying second order stream and second order stream, when they join together, we remain, or we are going to form a third order stream that is going to be formed. So our question is saying, what is the stream order? The stream order on, the stream order at X, it is just third order, which is C. It is C there. It is third order, which we are saying it is formed because of second order and second order joining, where we already have a high order, third order on top there. So it is third order stream. That is stream ordering. And question 2.1.6, question 2.1.6, the drainage density of a drainage basin is higher because it is influenced by the following in areas of dash and dash. So what we are saying is that drainage density, it is the number of streams that are found within a drainage basin, which we are saying is, if there are a drainage basin which has got a high rainfall, where the rainfall is too strong such that it does not have enough chance to cause infiltration, it would also cause high drainage density. So what we are saying is that in this case, a drainage density, it is synonymous to surface runoff. Factors that would influence surface runoff are more or less similar to the factors that would also result in drainage density. So what we are saying is that the more the streams are there, the more the density of a certain drainage basin. If the streams are less, we are saying there is low stream, there is what? The drainage density is low. High drainage density is whereby there are too many streams within a drainage basin. Low drainage density is whereby there are few streams which are caused either because there is enough infiltration of the water into the ground such that the water is not running off, causing more streams to be formed. So in this regard, what are the factors that can cause a high drainage density? What are the factors that can cause high drainage density? In question 2.1.6, we are saying it can be one, we are saying less vegetation cover. Less vegetation cover, it always causes what? Surface runoff. Less vegetation cover always result in high, causes a high runoff. And then we are saying there is also high porosity. Porosity is about the pore spaces which would allow the water to infiltrate. So this one cannot cause high drainage density. And then high rainfall, as I've said, high rainfall, it can also cause, high rainfall can also cause runoff, as to say that more water is raining and then the water is not able to sink or infiltrate into the ground. Hence, it can cause high drainage density. And then high permeability. Permeability is the ability of the landscape or the land surface to allow water to infiltrate. So if it is high, it means that water is infiltrating. So the point is that it should be answer B, which is saying answer B is the correct answer, which is less vegetation cover and high rainfall causes high drainage density. It causes high drainage density in a drainage basin. Low vegetation cover because the vegetation is to intercept the rainfall. So therefore the water cannot flow very fast. Hence, it reduces density, but in this case it is less. Therefore, it can cause what? It can cause more runoff. Question 2.1.8, refer to the trellis drainage pattern below to answer question 2.1.7 and 2.1.8. The tributaries of a trellis drainage pattern, dash, as you can see, the tributaries are the streams that are joining the main stream. We are saying this is a tributary, these are tributaries, and then we are saying this is the main stream. The main streams are those one which is along where the small streams are joining to, or where the small streams are joining to. So what we are saying is, what is the situation of the tributaries in a trellis drainage pattern? They join the main stream at an acute angle that is not correct. We are saying the tributaries in a trellis drainage pattern, they join the main stream at right angles. As you can see, the main streams are joined at right angles. That is a key descriptive feature of a trellis drainage pattern, that tributaries join the main streams at what? At right angles. So the answer 2.1.7, the answer is B. We are saying the tributaries, they join the main, the tributaries join the main stream at right angles. 2.1.8, this drainage pattern is found in a region of dash and dash. 2.1.8, this drainage pattern is found in an area of dash and dash. We are saying it is found in an area where we have got inclined strata and also where we have got folded strata. So we are saying in question 2.1.8, we are saying the tributaries are joining, 2.1.8, the answer is C. So having said that, these are short questions that we need to understand that they always come. However, sometimes they cause confusion, but we just need to understand that these questions are not supposed to cause us to lose any marks. This question refers to a river profile A and B. Complete the statements in column A with the options in column B. Write down only Y or Z next to the question numbers in the answer book. E.g., 2.1.8, let's say the answer is Y, therefore you write Y only. So like I was saying last time, we are doing comprehensive revision. So you need to understand to say that when you are given instructions, don't make mistakes. Just make sure that you follow the instructions per questions, per each question or per each part question that is given in the question paper. So in this case, we are given this. This is an ungraded river channel this is a graded, which I just want you to take note of, to say an ungraded channel, it has got an even profile. So this is ungraded. It is ungraded river profile. This one, it is graded. I think before we go anywhere, this is the first thing that any grade curve learner must understand, to say this is a graded and this is ungraded. And then the point is, how do you see that this is ungraded and this is graded? Ungraded river channel has got some temporary base levels which are formed by some resistant landscapes, which can be either some underlying rock strata which are just resistant, and also some temporary water storage reservoirs, such as the dams and the X things that are shown in diagram A there. And then the graded, it has got a smooth concave shape, which has got to show that there is a balance between erosion and deposition, such that there is a very smooth longitudinal profile of the river channel. That is one thing that we just need to take note of. And again, in this case, again, we might also need to know and need to understand that we can identify, to say, if we can say, define the river in its stream order, in these levels, we are saying this can be the upper course, this can be the middle course, and this can be the lower course. I'm sure that you must be able to know that, to say, in terms of the word classification of the longitudinal profile, we have got upper course, middle course, and lower course, and the characteristics thereof, they also vary, which would say that in the upper course we have got very steep river channels, we have got waterfalls, we have got headwater erosion that also dominates there, which results in gorges and stuff. Let's just quickly go to our question, and then we can quickly refer to them. Sketch A and B illustrate profile of a dash. Sketches A and B illustrate dash profile of a river. 2.1.1, we are saying, what is the sketch A and B? A and B, they illustrate what and what? What we are saying is that this is a longitudinal profile, because it is showing from the river source to the mouth. The longitudinal section, this is the longitudinal profile, which is illustrated from this, which is illustrated by from the source to the river mouth. We say it is it's a longitudinal profile. It's a longitudinal profile of a river. And then when we are talking about a cross sectional, we are talking about one river bank to the other, which is showing the river width and depth. That's when we talk about the cross-sectional view, which shows, like, to say, it will be just a cross-sectional view. It will be just something like this, to say it shows the river from one bank to the other, and also it shows the depth of the river channel. Therefore, this can show a cross section, then this one shows a longitudinal profile. So the question is saying, this profile A and B, it is illustrating the longitudinal profile, which is in this case 2.1.1, 2.2.1, we are saying the answer is Z. It is Z. Z is the longitudinal profile. And then 2.2.2, temporal base levels of erosion are evident in dash. The temporal base levels, as I've said, temporal base levels, these are some base levels that are caused because of some features that are found along the river channel, which we are saying they are shown on the profile of river. Temporal base levels are shown in profile A. As you can see, this is a temporal base level which is caused because of the resistance here, which we are saying a base level. We are talking about the level to which the river can erode to, which we are saying the permanent is when the river erodes to the permanent base level that is caused by the sea is the permanent. So any other base levels that are formed or that are found along the river profile, we call them temporal. So our question is saying, what is the temporal base levels? They are the answer is what? It is A, which we are saying the answer is, it is 2.2.2. The answer is Y, because we are saying Y is showing the temporal base levels, which is A. The profile of sketch B is dash. The profile of sketch B, the profile of sketch B, the profile of sketch B, which is this one. The profile of sketch B, the profile of sketch B, which is this is B. What is the profile of sketch B? Like I said, this is a graded profile because it is very smooth. It is equally balancing from the source to the end, to the mouth. So it is the profile of sketch B. It is what we are saying. The profile of sketch B. It is a graded, which is Y. Why it is graded? It is a graded profile. It is a graded profile. The profile of sketch B, it is graded. It is a graded profile there. And then the next question is saying the dominant process at X in sketch A is erosion, is dash erosion. The dominant process at X in sketch A is dash erosion. What we are saying is that in sketch A, there is a resistant rock there, which we are saying what causes that to happen is that there is a dominant of headward erosion, which would cause the waterfall that is being shown there to what? To form. So A, the dominant profile at X, it is headward erosion, which is also shown by Y. It is also shown by Y there, the dominant profile, which is shown there. And then the permanent base levels of erosion is dash. Like I said, the permanent base levels of erosion is the furthest point to which a river can erode to. The river cannot erode further than a sea. So the permanent base level, it is shown. Permanent is always shown by a what? By a sea. So that is to say that permanent base level is what? It is a sea. And then when we are talking about temporary, we refer it to say that temporary is caused because of a what? It's caused because of a dam or any other resistant features that might form or that might be found along the river profile. 2.1.6, in profile dash, there is an equilibrium between erosion and deposition. In profile dash, there is an equilibrium between erosion and deposition. I said equilibrium, we are talking about saying there is a balance between erosion and deposition that is caused or it is shown when a river profile is very smooth. So the balance can be seen in profile B, where we are saying that there is a smooth concave profile. There is a smooth concave profile here. This profile, it is smooth and then it is concave, which shows that it is what? That shows a balance between, to say, erosion is equals to deposition. Erosion is equal to deposition. Therefore, we can have a graded profile. So what we are saying is that the answer is, the question is saying a profile dash, in profile dash, there is an equilibrium between erosion and deposition. It is in profile B, which we are saying that the B, we have got an equilibrium between erosion and deposition, which we are saying the answer is Z. The answer is Z because that is where we have got a balance between erosion and deposition, which causes a river profile to be what? To be graded. Question 2.2.7, the river profile B developed due to dash. The profile B, it developed due to dash. We are saying profile B, profile B, this is the profile B. We are saying it developed due to dash. Profile B is this one. What can be the reasons that might have caused the profile B to develop? Profile B, river profile B developed due to dash. What can be that? Erosion of temporal base levels, the lowering of the watershed. What can be the reason why we have got profile B forming, we are saying it is because of erosion of temporal base levels. To say the temporal base levels has been, the temporal base levels were eroded. So when the temporal base levels are eroded, what happens is that we would have a profile that is, like this. We are saying when these are called temporal base levels. This is temporal. This is temporal again. So what we are saying is that these levels of erosion, if they are equally eaten off, will end up having a river profile that will be just flowing in a concave shape. So what we are saying, it is formed as a result of erosion of temporal base levels, which is to say that the answer is what? The answer is Y. The answer is Y, because there is erosion of temporal base levels, which would result in the profile B being formed. So in terms of these river profiles, I just wish you that you understand that temporal base levels are formed as a result of fluvial landforms that are forming along the river profile, whereby the river is only eroding to those levels that are of those features, but the permanent base level is caused by the erosive power of the river when it erodes to the depth of the sea level, which is the permanent base level. We have got the question 2.3, refer to the photograph of a river below to answer questions 2.3.1 and 2.3.3. This is a cross-sectional view of a river channel, which is shown by a photograph here. The valley in the photograph is generally found in the dash course of the river channel. What is being asked here is to say, when we see a river channel, which is a cross-sectional view of a river channel, which is V-shaped river channels, what are we saying? We are saying V-shaped river channels are found on the upper course of the river channel. We also see there are interlocking space there, which we are seeing, as you can see here, you can see there, you can see this is a point of intersection, and then we also have another point of intersection there. So what we are saying is that this photograph is generally found in the upper course of a river channel. Question 2.1.3. This is on the upper course. This is found on the upper course. It is found on the upper course. That's the thing. That's the answer in this regard. Identify two characteristics visible in the photograph to support the answer above. What is it that is gonna make us to understand that this is found in the upper course? Why do we say that it is in the upper course? Like I said, we have got very deep valleys that you can see. This is a depth of a valley that is being illustrated there to say our valleys are very deep. As you can see, the valleys are very deep. So we are saying evidence that are shown in this case to support the answers there. We have got deep valleys that are there. Deep valleys are visible there. There is evidence of deep valleys. We also have the valleys are V-shaped, as you can see there. V-shaped streams. V-shaped stream. This is also clear there that the streams are V-shaped, as you can see in our photograph there. Like I've illustrated that these are V-shaped as a result of deep undercutting, which causes the river to be very deep, to be very deep like that. We have got steep slopes. As you can see, these are very steep slopes there. Very steep slopes that are shown there. We have got very steep slopes there. Steep slopes are evident on the photograph there. We have got steep slopes that are evident there, which we can say these deep valleys can also be defined as what? As river gorges. very very deep valleys, which we can say river gorges are also there, which are caused because of the river adjusting toward their sources. Then it eats back and then causes gorges to form there. We have got dominant or vertical erosion. Dominant of vertical erosion is shown there. Dominant of vertical erosion is evident in the photograph there. We can as well identify the interlocking spars that I've been showing there, the interlocking space that are visible in our photograph there. Interlocking space there. We have got interlocking space there. The interlocking space, these are shown, as you can see, that our we have got points which the river is gradually eroding to, which we can see there. It is eroding to there, and then they join there. We have got also where it is joining, where it joins there. We have got those tips. So as you can see, we are having even somewhere we can also even give some evidence of either some waterfalls that are shown there. As you can see there, the water is falling from high levels there. These are also features that can be identified in the upper course of the river channel, which are also evident from our photograph there. They are showing evidence of vertical erosion, evidence of steep slopes, evidence of interlocking space, and as well as deep valleys that are V-shaped, which we can see together on the photograph there. And then question 2.3.3, it's a waterfall that is shown there. Define a waterfall. Define a waterfall. Question 2.3.3. 2.3.3. What is a waterfall? A waterfall, as you can see, this is where to say the water is flowing, and then it falls over a resistant rock surface, and then underneath there is a less resistant rock which forms there, where it is going to form a plunge pool where the water falls there. There is a plunge pool which forms where the water forms there, which is caused because of the residues of the resistant rocks that are falling with the force, eating and causing some deep undercutting here, which would cause a plunge pool to form. So what we are saying is that it is a body of river water falling over hard resistant rock or a cliff. A body of water a body of water that is falling over a hard resistant, falling over a hard resistant, which is a hard resistant rock that is also steep, hard resistant rock that is steep, or it can also be hard resistant rock or a steep cliff. Hence, it forms a plunge pool underneath where the water falls. It forming a body of water falling over a hard resistant rock or a steep cliff. It is called a what? It is called a waterfall. It is called a waterfall. Falling over a hard resistant rock steep or a steep cliff, that is a waterfall. As you can see, in other words, again, we can say that a body of water that is, or a river flowing over a hard resistant rock overlying a less resistant rock, which the resistant rock forms an overhang, which the water flows on, and then it loses contact, then it falls down, forming a plunge pool. As you can see, these are broken rocks, which we can say are the residues that are forming as a result of what? These are the peeling off or the broken rock resistant rock pieces that have fallen up there, and then they cause the plunge pool to deepen up as erosion continues there. 2.3.4, 2.3.4, 2.3.4, 2.3.4. What's the question saying? 2.3.4. Match Y and Z in the sketch A with the concept resistant. Match Y and Z in the sketch A, which is sketch A. We are referring to this sketch A. Match them with the concept resistant rock and less resistant soft rock. So what we are saying is that Y is the board or the shaded black part. This is a resistant rock, this one. Y is forming a resistant. Y it is resistant rock. Y is resistant rock, and Z is less resistant. Z is less resistant rock, which is being eaten off or which is being corroded there, and then causing an overhang to form. Question 2.3.5. How does erosion in sketch B cause the waterfall to retreat or move upstream? 2.3.5. 2.3.5. How does the erosion in sketch B cause the waterfall to retreat or move upstream? In this case, what is happening is that we need to understand to say, how does erosion cause a waterfall to retreat? Retreating, we are saying when the waterfall moves upstream, how does that happen? How does that happen there? 2.3.5, how does the retreat take place? How does this retreat take place? We are saying the soft rock is eroded, leaving the overhang. Soft rock, which is Z there, is eroded. Soft rock, which is Z there, this Z is eroded. As you can see, it is curving inside. Soft rock Z is eroded and then leaving the hard rock exposed. It leaves the hard rock. It leaves the hard rock exposed. It leaves the hard rock exposed, and then erosion, which is of the less resistant rock, occurs. As you can see, the soft rock of soft rock it occurs, and then what happens there, which will create a plunge pool when this resistant rock falls. The overhang of the hard resistant rock, the overhang of the hard resistant rock, it breaks off. As you can see, this the broken lines that are shown here, they are showing the retreating or the back movement or the upstream movement of the waterfall. So what happens is that this piece, which is in stream B or in photograph B, which we are saying this one, it remains there, and then because it is not being supported underneath, the overhang becomes heavy, and then it breaks off, causing the movement of the waterfall to move backwards. It starts to move backwards, which we are saying the movement, or it causes the migration, the retreating of the waterfall. So this movement, it is caused as a result, the overhang of the hard resistant rock breaks and forms plunge pool at the base of the waterfall. The overhang, it breaks and then forms a plunge pool there. So what happens there, when the collapsing or falling of the hard resistant rock backwards causes the waterfall to move also. Waterfall to retreat. The falling of the resistant rock because of no support under it causes the waterfall to retreat or to move upwards. So basically what we are saying is that in the main concept is that there is an overhang that is caused as a result of the resistant rock from which the water flows over, and then this resistant rock it ends up being exposed without being supported. Therefore it becomes heavy. When it becomes heavy, it migrates backwards as a result of the breaking off or of the peeling off of that resistant rock. As it peels off, hence we are saying the waterfall is retreating, or it is moving upstream. It is moving back towards the source. That's what is taking place there. That is what is taking place, which is usually also supposed to be understood, that it is supposed to be known. You need to understand that this process of the retreat is also caused as a result of headward erosion. Sometimes they would ask you to say what form of erosion is dominating there. So it is headward erosion that would also cause this process to take place. Our next question, the sketch below shows river rejuvenation. What is the sketch below shows the river rejuvenation. What is river rejuvenation? Last time we did waterfall. We did river capture in our last question. Today we are talking about river rejuvenation, which we are saying it is also the situation. Rejuvenation of a river or regaining of energy by a river is what you call river rejuvenation, which would also be caused as a result of which is sometimes caused as a result of river capture. So I would want you to understand that river rejuvenation is a process whereby a river regains its energy and it begins to erode vertically or downwards again, which would result in a river forming within a river, or a river within what you call a river forming within a river, or incest rivers. So the definition is that river rejuvenation is a process by which a river regains its energy. A river regains its energy such that it can erode. It can erode vertically, or it can cause downward erosion again. It can erode vertically. So what happens is that a river has been flowing, but either it was just having a low discharge. It might be because the river was not having enough energy. So because of many other factors that might cause the river to gain its energy, that we are going to look at as to state two possible causes of river rejuvenation. state two possible causes of river rejuvenation. I want you to check and understand this to say the possible causes, state possible causes of river rejuvenation. What can be the reasons? What causes the river to rejuvenate? What can cause the river to regain its energy? Causes of river rejuvenation. Causes. What are the causes of river rejuvenation? Causes of river rejuvenation. What are the causes of river rejuvenation? What causes a river to regain its strength? One, we are saying change in gradient. It can be one, a change in river gradient. A change in river gradient can cause a river to gain its energy, which we are saying is a result of either a drop in the sea level, a change of gradient, either caused due to drop of sea level. So when the river, remember to say when a river flows from the source to the mouth, as it flows from the upper coast to the lower coast, we are saying the rivers, they run and then they end emptying their waters into the sea. So when the sea level drops, what happens is that the movement of water up the stream there, or the movement of waters from the streams that are entering the sea, they increase their flow because there is a capacity that has been created in the sea, which would enable the rivers to drain strong into the sea or to increase their energy. So a drop in the sea level can also be a reason of a change in gradient of a river channel, which would increase the energy of the river. Hence, we are saying that is what is river rejuvenation. It can also be because of an increase in river discharge. Another point, because river rejuvenation can be caused by increase in river volume or discharge. We are saying the discharge is the amount of water that is within a stream, which we are saying the amount of water in the stream. What is that? It is whereby to say many streams might have entered into the main stream, which would cause the lower stream, or to cause to say this stream which is being emptied by the other rivers there, where the rivers are emptying their waters into, it increases. We are saying increase in the river volume or discharge, which can be caused because or due to river capture. Like we said before, that river capture can also be a reason that can cause river capture, or either it can be just joining of any other tributaries, river capture, or joining of more power still tributaries, joining of more powerful tributaries. When the powerful tributaries join the main stream, it is possible that the stream can be able to increase its energy. So a change in gradient is a cause of river rejuvenation. An increase in river discharge or volume can also cause river to rejuvenate, which can also be very honest and true to say that rivers can also be able to rejuvenate as a result of a change in times, as to say a river has been in a basin which has been experiencing prolonged droughts. So after periods of droughts, there is a time whereby either to say there is an increase in river, in rainfall totals. That increase in rainfall totals would increase the volumes of the rivers, whereby to say any other deposits that has been formed or that have been established in the river course are going to be eroded off, resulting in what we call river rejuvenation. That's what we call river rejuvenation. So the next question is saying, draw a labeled freehand section, cross section from A to B of the illustrated river rejuvenation. Draw. The question wants us to draw A to B of a cross section of the illustrated river rejuvenation. That is there. Marks will be allocated for shape of the rejuvenated valley, indication of the new floodplain, indication of the river terraces. And then we want to draw a cross-sectional view of this river of the rejuvenated river channel. We want to draw the cross-sectional view of the rejuvenated river channel. So what we are saying is that we are supposed to understand that when a river rejuvenates, the energy is regained, and then the regaining of the energy is what we need to understand, that we need to understand those systems. So let us quickly just draw a labeled freehand cross section from A to B of you see the river terraces there, and then A to B, which we are seeing that those are the river banks, and then that's the stream within a stream there, which is shown through a meander being almost undercut again. So we want to draw this. We want to draw this this cross sectional view. It's question 2.4.3, cross sectional view of a river rejuvenation. Cross-sectional view of river rejuvenation. So our question 2.4.3, 2.4.3, 2.4.3. The question wants us to draw a cross-section of rejuvenated valley. So our title is saying, our title should say cross-section. Our title, cross-section it is a cross-section cross-section of rejuvenated valley. Of rejuvenated valley. So what we are asked to do here, we need to draw a cross-section of a rejuvenated valley. In this case, what these people are just asking us is just for us to illustrate that we understand a cross-section of a rejuvenated river valley. How does it look like? That's the question. That's what the question actually wants us to. That's what the examiner is trying to show us here, to indicate to us that do we understand the process of river rejuvenation? How does it look like? The question, the examiner just wants us to quickly just illustrate a diagram of this. So what we are saying is river terraces are the steps that are formed. So we are saying the river terraces, you can see this and that. These are the terraces. These are terraces. Terraces are just steps along or within a river valley. That are the terraces. And then the question wants us also to indicate the terraces. And then, as you can see, our floodplain is to say, how does this flooding going to take place? We are going to see our river flooding as to like this. So our new floodplain, this indicates it indicates the new floodplain there. The new floodplain is indicated by this and that. This is the new floodplain that we are showing here, which is shown by the shaded region there, which we are saying this is now our new river there, which we are saying this is our river there. So in other words, we are saying the stream has been flowing, it has been flowing from there. It has been flowing from there to there. But what happens is that because of either it might be because that there was a moment of low discharge and other reasons. We are saying the broken line that I'm giving, the broken line that I'm showing here, the broken line that I'm showing here, it is not asked anyway, but I'm just trying to answer the question comprehensively. So to say the broken line, it is showing us the what? The odd, it is showing us the oddest floodplain. It is showing us the oldest floodplain. The oldest floodplain, which we are saying it was the oldest. And then we can go as the river is making the steps. So the first steps from the upper course, from the onset is the oldest. And then the second step forms the new plain until we go to the new channel which the river is flowing within. So we are saying the stepped terraces are showing the movement or the migration of the floodplain, which is supposed to be understood by a geography learner, that the floodplain are showing the different river width that the river has been flowing over a period of time. So I'm sure that you must be able to understand this, to say this is our new river which is flowing there. And then the question wants you to indicate those items. The question wants us to indicate those items. Let's quickly check the next question. Let us quickly check the next question. That's what is the question saying? We did draw, we showed the shape of the rejuvenated valley. Shape of the rejuvenated valley, we have shown it. The shape of the rejuvenated valley, indication of the new floodplain, indication of the river terraces, which I'm saying these are shown in our diagram that we have drawn here. The cross section of rejuvenated river valley, we are saying they are the terraces are shown there. The terraces are shown, which we are saying these are the terraces that we have shown here. Those are the terraces. The new floodplain is shown there. The new floodplain, and then we are saying the stream channel, and then the oldest. It's not, of course, asked, but that is what the question wants us to see. So there is marks for caption, which is the title, cross-section of a rejuvenated valley, and then we have drawn our diagram like that. Maybe for perfection's sake, we can either even, we can also maybe put our diagram in some borders. We can just need to put our diagram in some borders such that the examiner can also see that this is the borders that are supposed to be shown there. So we are saying for perfection's sake, we can as well put the borders there. It's just to show that that is our, that's the frame of our river channel. It's like that. So cross-section of a floodplain that is being indicated there, that is being indicated. So I'm sure you have seen this. Let us quickly just go to the next question. The next question is 2.44. 2.44 question is saying, how did the river terraces illustrated in sketch form? How do the river terraces form? I'm saying the terraces, these are the steps of the river channel. How do the terraces form? How do the terraces form? Question 2.44. Question 2.44. How do the terraces form? One, we need to understand that a rejuvenated river cuts into the valley floor. A rejuvenated river, the rejuvenated river cuts into the valley floor. It cuts into the valley floor. How do terraces form? We are saying the rejuvenated river cuts into the valley floor. That must be understood. And then undercutting creates a new floodplain. Undercutting creates a new floodplain. Undercutting creates a new floodplain, and then steps form between the old and the new floodplain, resulting in steps forming between the new and old floodplain, between the new and old, between the new and old floodplain, between the new new and old floodplain. That's how the thing. We are saying when the river rejuvenates, it undercuts into the valley floor. When it undercuts into the valley floor, it causes, it undercuts into the valley floor, it undercuts into the valley floor, and then it creates some, creating a new floodplain, which you are seeing from this diagram that I've just drawn, or from our diagram that we just drew there, our diagram that we drew, which is showing the rejuvenated river valley. If you can see our diagram that we drew here, what is happening is that the terraces are the steps that we are referring to. These are the steps here, to say the steps that are being formed. It is because of the undercutting of the river channel, or of the stream, as it regains the energy. So it keeps on incising, it incises, or it cuts deep into the old stream, that the water is going to be concentrated within the smaller, within or along a smaller part of the river channel, which would cause the steps to form. So the forming of the steps is what we call the terraces. The forming of the steps is what you call, rejuvenation, and it's what you call the terraces, which you can see just a replica or a resemblance of a stadium that you can see there, to say, as we see in a stadium, we have got the high tables or high chairs, low chairs and stuff, as they are moving up along the vertical dissection of the stadium, like that. So basically what we are saying is that the terraces are formed because of the undercutting of the rejuvenated stream, which it incises into the old stream, causing some old and new floodplain to form, which will result in the steps forming there. And then question 2.4.5, explain how the illustrated landscape will negatively impact on infrastructure development. So the question would want us to understand, or to relate to, say, the steepness and the formation of the floodplains. How do they affect it in terms of infrastructural development? Question 2.4.5. Question 2.4.5. The question is saying, illustrate how landscape will negatively impact on infrastructure development. So in this regard, we are talking about the steepness, the issue of the terraces, the issue of the floodplains. How do they affect infrastructure development? So steepness of the slope will hamper construction of what? We are saying one, steepness of the slope it will hamper construction of roads. It can hamper construction of railways. It can also even affect, we are saying, railway line development or establishment. They are affected because of the steepness of the slopes. Two, what else can be the problem having there? We are saying softness of the undercutting rock causes instability of roads and railway construction, which we are saying the incision that is taking place, the undercutting that is taking place there. So what happens is there, we are talking, there is an issue of softness, the softness of the underlying rocks. The underlying rocks, the softness of the underlying rocks causes instability of roads and railway construction, causes instability of road or railway lines. So as we can see, our railways or roads cannot be stable because of the what? Because of the instability or because of the softness that is there. It is not firm enough to hold whenever sometimes it rains. You remember, sometimes we might have heavy rainfalls that might also cause earth movements. So in terms of, because of the softness that is in here, it results in such issues that would affect the stability of our infrastructure. And then terraces the terraces that we have given there also, it makes it difficult to build bridges. Terraces may make construction of bridges expensive. Construction of bridges more expensive. Unlike to say we have got a river that is equally, that is just stable or that is equally the same. So the terraces that are there, they make bridging also being difficult. As you see, we need to have roads that can cut or that can cross places. So that can be difficult also. Lastly, what does the floodplains do? The floodplains can also make it difficult to build bridges again. Floodplains make it expensive to build bridges as well. So bridges can also be difficult to build because of the landscape. How the question wanted us to explain how the illustrated landscape will negatively impact on the infrastructure development. So in this regard, we are basically looking at the landscape or the issues to do of river capture, the scenario that is formed there. How does it impact in terms of the roads and railway development or transport networking? So there is an issue of terraces that also makes it difficult. The floodplain, the also softness, underlying rocks causes instability and as well as the steepness that are being formed as the slope, on the slopes there, resulting in what? Resulting in construction of roads and railway lines difficult as well. We can go to the next question. We can go to the next question. The next question is referring to extracts below on catchment and river management. Like I said, today we are just looking at what? We are basically looking at geomorphology. So the question is saying, refers to an extract of catchment and river management. The catchment of river management. So let us quickly just rush to the question. The article is given that large volumes of potentially toxic coal mine waste have spilled into river flowing through rural communities and the Umfolos Game Reserve. According to the US-based Union of Concerned Scientists, mining and coal washing operations produce high water pollution, which can also contain toxic heavy metals such as arsenic, copper, lead, and manganese. When the slurry dam was collapsing on 24 December, the residents of the affected communities were not warned about the potential hazards until 2 weeks later. Conservation managers in the neighboring close and follows game reserve were also led to believe that the spill was under control, only to discover pitch black water flowing through the reserve several days later. By this stage, the black water has reached the confluence, which is a joining point of the black and white Umfolos rivers. A slurry dam, it is a dam that is used to store byproducts of mining operations after separating the ore. Question number 2.5.1. 2.5.1, what caused the river to change its color to black? What caused the river to change its color to black? I'm sure this question is quite good because we refer to what? To the to our comprehension or to the reference given in our question there. So 2.5.1, what caused the river to change its color to black? One, we are saying coal mine waste have spilled into the rivers. As you can see, coal mine water influent have spilled. We have got the spilling of waste here. So we are saying it was coal mine waste spilled into the river. There is a spillage of waste of coal mine waste that entered the river there. We can also talk about just saying polluted mine waste based from the slurry dam. It can also be possible to say polluted mine waste based from the slurry dam. Mine waste based from the slurry dam. So we are saying the dam that is containing the mine waste, as you can see, we are talking about the slurry dam there, which contains the byproducts of mining operations, which we are saying discover the black waters that has been flowing in the river through their reserve later on. That is one thing that is shown there. And then the question 2.5.2, 2.5.2, state two toxic heavy metals in the extract that could be found in the polluted mine water. We have already seen paragraph number 2. Mining coal washing operations produce high water pollution, which can also contain toxic heavy metals, which is these ones that are shown there. So we have got arsenic, copper, is given in the paragraph there. Arsenic copper is given there. There is arsenic copper there. We have got also lead. There's also another heavy metal that can be found there. We can also talk about the third one, manganese, that is also given in our extract. So questions such as these ones, classy, you need to understand that you don't need to lose any marks because the answers are given in the what? In the context. The answers are given in the context there. Question 2.5.3, quote one phrase from the extract that indicates that the mining company did not disclose. The mining company did not disclose. It did not disclose, did not make it known to the pollution of the rivers there. They did not disclose. What shows that they did not disclose? We are saying there are issues of saying the residents, one, when the slurry dam was collapsed, the residents of the affected community were not warned about this. The residents were not, the communities of the affected areas were not warned. We talk about here communities not being warned, and also we talk about the promise of under control, which the reserve also led to believe that the spill was under control, only to discover there was no, they were not warned, because if they were warned, they could have known that the flooding or the spill over was not under control. So 2.5.3, residents of the affected communities were not warned about the potential hazards. Residents were not warned about potential hazards. They were not warned about potential hazards. They were not warned about potential hazards. That is there until 2 weeks later. Until 2 weeks. It is shown in the paragraph that they were not known until 2 weeks later, which is given here. Until 2 weeks later, it is marked in our essay, in our essay there. Conservation managers in the neighboring rivers game reserve were also led to believe that the spill was under control. It is also showing that conservation managers, we can also talk about the conservation managers were also, just to say another point there, conservation managers in the neighboring Sohlue, Umfolozi, game reserve were also made to believe that the spill was under control. They were also made to believe the spill was under control. So we are saying these are some of the points that are there, which indicates that there was not enough communication with regards to the effect of this spilling over that has been happening there. That is correct to say that. What could have been 2.5.4 what could have been 2.5.4, what could have been the negative economic impact of non-disclosure on the community? This condition or this scenario of not communicating to the community, what could have been the negative economic impact to the community of this non-disclosure? We are saying having this occurring without telling the community what is the negative economic impact of this negative economic impact of non-disclosure in terms of the spill, the negative economic impact of non-disclosure is what the question wants us to talk about. Number 2.5.4. 2.5.4, negative economic impact of non-disclosure about spill off, or let's just say spillage. What are the negative economic impact that might have occurred or that would arise the non-disclosure? One, we are saying what could happen there? We are talking about ecotourism affected. Ecotourism being affected. We are saying our ecotourism is going to be affected because the people or the responsible authorities are not aware. We can also we need also to talk about future investment in the communities is limited because people are afraid. Future investment is limited. Future investment is limited in the community. Future investment in the community is limited because people are afraid, is limited in the community because people will be afraid of this scenario. We can also need to talk about contamination of agricultural products. Contamination of agricultural product might arise also as another economic impact that might arise. Contamination of agricultural produce. We are saying the spillover and the black waters that we are seeing there would cause contamination of agricultural produce that would reduce their selling. It can also, another economic impact, it also increase in medical bills. When people get sick, going to hospitals and stuff, that would also impact in terms of their businesses, or in terms of the monies and stuff. We can also maybe want to talk about expensiveness or increase in the budget of purification of water. Increase in cost on water purification. On water purification. On water purification. Purification of water becomes another cost that must need or that need to be taken care of. Question. Let's quickly answer last question 2.5. Question 2.5. Question 2.5. Question 2.5. Question 2.5, it wants us to look on paragraph of approximately 8 lines, describe the environmental importance of managing the Umfolozi drainage basin and suggest measures that the local municipality could implement to maintain the future quality of water. So basically the question would want us to talk about drainage basin management. That's what the answer, that is where we are focusing on 2.5.5, we are saying describe environmental importance of managing umfolo. So the question has got two parts. We need to talk about the importance of managing the quality of water, importance of managing the drainage basin, and also suggest measures that could the local municipality put to implement to maintain water quality. So we are talking about importance first. Always make sure that when you answer these questions, identify all the parts of the question. So the first question is importance of managing the drainage basin. One, to ensure the quality, to ensure maintaining one, we can say what are the importance of this one? One, to ensure the availability of water, to ensure availability of water. We need to ensure availability of water by drainage basin management. Availability of water is maintained, or it is ensured by maintenance or management of drainage basins. We can also need to preserve aquatic life, preservation of aquatic life. We are talking about life of organisms that are living in the waters. They need to also survive. So by doing drainage basin management, they are also being preserved, or they are also being taken care of. It also ensures the healthy balance of the ecosystem. Ensure that the ecosystem remain in good health. Ecosystem remain in good health. That we are saying the interrelatedness or the interdependence of organisms in the environment, it remains healthy because the organisms, there is drainage basin management, which also ensures that, I'm sure again, we also need to maintain water quality. To maintain water quality. Drainage basin need to be managed in order to maintain water quality. These are quite some of the points that we can also put in place. And also, we can as well lastly say preservation of habitats and biodiversity. Preservation of habitats and biodiversity. Like the variety of organisms in their ecosystem, it increases also because of the habitats that is being preserved. Because drainage basin, it is quite a lot of interdependent factors, or it is actually has a lot to do with habitat preservation, which would also ensure that habitats are preserved, which also at the end of the day increase biodiversity or the variety of organisms in their different appearances. And then the question also wants us to suggest measures that the local municipality could implement to maintain the future quality of water. So we want measures to maintain future quality of water, measures to put in place to maintain future quality of water. Future quality. Measures to put in place to maintain future quality of water. What are these measures that we can put in place to maintain future quality of water? We can talk about one, continuous monitoring of dams, continuous monitoring of dams. That dams are well managed. It helps to make sure that the quality of water is ensured. We also need to conserve our natural vegetation and drainage basin. Conservation. We are saying conservation of natural vegetation. Conservation of natural vegetation and drainage basin. And drainage basins. We can also talk about measures, impose fines to companies which do not comply with regulations. Impose strong deterring fines to companies failing to comply with national regulations. So companies that do not want to comply, they might need to be also put, or they need to pay some strong fines, which can make them to be afraid to fail to comply. That will be also a good measure that can also control that. We can also talk about promotion of sustainable farming methods. Sustainable farming methods. Sustainable farming methods, we are talking about farming practices that would also not interfere or not affect the drainage basins and also the river systems. This is to do with farming away from rivers, specific goods required meters. You can talk about avoiding cutting down of trees, any other environmentally friendly practices that would relate to good farming practices. We need also to educate education of communities on the precautionary measures. Education of communities. Class, I would want you to understand that in any case, most times when we are asked to give questions or to give solutions, wherever there is a problem, always understand that education is a best, it is always a best solution. It is always a correct solution in any given scenario. Education of communities in terms of the importance of good water quality, in terms of the importance of drainage basins is quite important again. We need also to control extraction of groundwater. Control extraction of groundwater. The extraction of groundwater must be well managed because groundwater, you know, that it is one of our key water supply, which needs to be quite managed in order to avoid problems and also depletion as well as contamination. Last but not least, we can also talk about frequent testing of quality of water. Frequent testing of quality of water. When water quality is frequently tested, we can also ensure that the water quality it is well of, I mean, it is of good standards. The last answer that I can give right now is regular maintenance of dams to avoid flooding. Also, regular maintenance of dams. Dams must be well maintained, either fencing, dam walls, or other ways that would avoid the waters to be made dirty by either animals that can maybe depend on those dams, or either by any other trespassers that might also enter through there. So legislation and government policies can also be a good way or a good solution towards problems that might arise, to say that the government must also implement strong policies and legislation in regard to that. And then I'm sure that this one, we might not need to forget it, because it also relates to our other chapter, which has to do with the GIS, which has to do with implementation of good buffering system, implementing good buffering system, which would also avoid creation of good buffer. You are saying the buffering system or a buffering system or a zone. I think buffering zone can be the best. Creation of good buffering zone. Creation of good buffering zone. Good buffering zone, which is also very important, which we are saying around slurry dams, the buffering zone that we want, buffering zone around slurry dams, buffering around slurry dams. So thank you very much, Classy. I hope that you are going to get a good understanding and a good benefit of this lesson. Don't forget to subscribe. We have done quite a lot in terms of hydrology, I mean, and geomorphology. So we are still to find many other questions that you are going to bring here for the interest of revision and also clarity, such that we get good marks. I'm sure that with the human geography, it is not quite difficult, unlike physical. So look forward for your next audio or next presentation that is still on physical geography. Climatology and geomorphology is still going to be 2 or more videos that would come. Thank you so much and have a good day. Don't forget to subscribe. You have yourself a beautiful day. Thank you so much.